presenter is Professor GTF Silva. I don't think I need to introduce him. Everybody know him, including our students, and including myself. I was honorable student of Professor GTF Silva in 1981. I can even tell the dates. And most of us, Professor Gyan Dias, I am sure, and anybody who attended Moratuwa 30 years ago or 35 years ago. Professor Silva was Vice Chancellor of Moratuwa University 2 terms. Served University of Moratuwa as a lecturer, head of the Department of Mathematics, and as the Vice Chancellor 2 terms. He was the Director General of SLI ATE and Managing Director of Media Defined. I didn't know that. The Sri Lankan branch of USA company working in e-learning. Currently he is attached to the Department of IT and M at KDU. That's mathematics. He holds DIC and MPhil in mathematics and computing, and DPhil from University of Moratuwa, MBCS, CEng and MBIS. I thought MBCS will be MBBS, but Professor Silva, you are now, if you are ready.
Thank you very much, Mr. Chairman, for the. He's an honored student, as I said. Yes, he said. Well, and colleagues, like the chairman, I am also standing for somebody else. My other colleague, his name was not in the proceeding, so there was confusion. So I had to take this place. So now these things happen in software, I think. His name was replaced by an unknown name. So now my work is on cost estimation of accelerating a project. Now you all know this is a project now, but they have organized today. You have activities which are logically connected. You have starting point, end point. So now we are maybe about 2/3 way of this project. Maybe another 1.5 hours more to go. Our chairman might all of a sudden say, I want to finish this in 1 hour, not 1.5 hours. That is called crashing or accelerating a project. So some of the project managers, this happens very often in building projects in the ministries. The minister will ask how long we are going to take. They will say another 6 months. No, I want it in 3 months. So the project manager will say, yes, sir, I will do it. But at the end, he will get into trouble. So for that, the managers should give a cost. Okay, I can do this, provided you give me extra. Now, the problem is people don't know how much extra to ask. So that is the thing we are looking at. So as you know, project is modeled as a network of logically connected activities from start to end. So this is one example of an activity. So you have earlier start over that's not really necessary at this stage. Now, how do we estimate the duration or time taken for an activity? Now, I presented a paper like this about 30 years back, and people were not happy. I only, when I put up my house, critical path activity. So, I base my activities on my experiences, foundation, so many weeks, like that. But PERT, so there are two things. Critical path was normally done by the British. The Americans introduced this PERT, which is you ask three people how long this will take. One person will be very optimistic, say to lay the foundation, person will say 1 week is enough. Then on the other side you will have pessimistic people, they will say no, it will take 4 weeks, 5 weeks. Then you ask a moderate person, that will give a middle value. So these are heuristic methods you have to apply. You see, you can't calculate or measure these things. So they use Simpson's rule for this. That is, you take for the duration, this formula you can see, 16A, that is the optimistic value, plus 4B, plus C. I am sure this is well known. But for costing, there is no such thing. As far as we have found, we have gone through number of references, websites. We have not come across a model to get the cost estimation. Now this is an example of some arbitrary network. So you can see the critical path going by 2 arrows. Well, I am not going to, I am sure most of you know this. So this, based on these values you can see in the next slide. So activity 1 to 2, these are the optimistic, moderate, pessimistic and the value calculated. Now supposing we want to accelerate this maybe halfway. Now if you come back to this, maybe at the third node, this circle here, you want to accelerate this. That means it will take another 22 days, 22 units of time, but somebody will come and say, I want this in 14 units. Now the first thing is to find whether it is feasible. Simply because your minister or somebody says, do this quickly, you have to first find whether it is feasible. Then the other thing is the extra cost. So that's the new idea we thought in giving this paper. Now what is in the books, in the literature is, you go through the balanced network and find for each activity on the critical path something called cost slope, which is cost slope for any activity you find in the balance activities of the critical path. That is crash cost minus normal cost divided by normal duration minus crash duration. So we have the figure for normal duration, but the other three terms are not there. So what we are proposing is a new model to estimate the crash cost, normal cost and the crash duration. Now the idea we propose here is to bring the PERT for this. So like earlier, for the cost we asked three people. Now in capital letters we have given the cost values. Here. Now say capital A is the optimistic cost, D is the moderate, C is the, so what we now say is this. For the crash cost, that means how quickly you can do this, take the C value. That is the most pessimistic value given. Take that as the crash cost. That will be very large, isn't it? Than the normal cost, which is calculated using this Simpson rule. So that will look after, well, let's see. So where is that other thing? Yeah. So for crash cost we use capital the pessimistic value, right?